So we are live now. Okay. So welcome all to this webinar series, ship navigation and route optimization. There's a series of presentations today, and there's a series of presentations tomorrow. My name is Soren Vinther Hansen. I'm the moderator of this event, and I'll lead you through this afternoon's discussions and presentations. So this is about ship navigation and route optimization, and where safety is a key parameter. Every year we see container losses, we see damages to cargo, to crew, we see lives lost. So safe navigation and optimized ship routes, they are essential for ship and crew safety. But efficient ship routes and navigation is not only crucial for safety, it also benefits fuel and time, which helps owners to meet the financial and environmental goals. On this two-day online event, our aim is to discuss more about some topics within this area, and some of them are guidelines for safe ship navigation, autonomous ship reality and future AI-based navigation systems, ship speed variation, minimizing fuel oil consumption and time by route planning, maximum efficiency by analyzing data, and weather forecasting methods for voyage efficiency. So our mission is to identify cost-effective solutions to enhance vessel safety and efficiency while protecting the environment. So we are happy to welcome you all for these two-day discussions. Today's discussions are sponsored by VesOPS, which is represented by me. Navtor, StormGeo, and Wärtsilä are sponsors for this event also. We will go with presentations for 1.5 hours, and then there'll be a Q&A session at the end of the presentation rounds. And if you have any questions during the presentations, feel free to put them in the Q&A section, and we'll relay them to the presenters so you can get some answers on your questions. We have an impressive lineup of presenters today. We have 5. We have both from owners and operators side, but also from the service provider side. And I think we will start with the first. The first one is from TORM, shipping company TORM. This is Lajos Holmslykke. Lajos, he has large experience as a sailing master mariner. He's been working in Maersk for some years, and now he's in TORM, where he's heading up the commercial voyage optimization. And he's handling routing and optimization while vessels are on the way, and how to improve that. We were not sure about Lajos' connectivity today, so we have recorded his presentation, but he will be available for the Q&A section later on. So if you want to start Lajos' presentations, we are ready.
Good day. First of all, thanks for allowing me to present on this very relevant topic for this conference in ship navigation and route optimization. This is a recorded presentation, as I'll be traveling on the day of the conference. I will dial in answering questions if there are any. I have chosen the topic around TORM's continued effort to optimize our vessels, routes and digitalizations, as these two topics are very closely related in TORM, where we now have spent nearly 3 years in developing our strategy while implementing a significant number of developments resulting in a more safe transfer of our assets, as well as improving the voyage consumption due to avoiding bad weather. We are daily working with many developers and suppliers, including universities, to gain better understanding in areas where we can improve. In TORM, we operate and own more than 80 vessels. This is a major benefit considering the need for education and training. Our vessels are all tankers, quite often positioned for many months in certain regions of the world. So why do we do routing? Well, one of the reasons is seasonality. Very often we see our vessels in conditions out of their comfort zone because they maybe have been in very good weather areas for many months, and then suddenly they are being sent to a cross-Pacific voyage in the heavy weather season. We can share experiences from other colleagues, benefiting the overall results, and results are often, especially in the bad weather season, savings between 10 to 15% on the voyage by taking the most optimal route, obviously pending season. What we do in terms of voyage optimization is that we gather all our data. We are able to benefit the entire process, calculating more accurately the voyage cost before starting a voyage till analyzing the voyage after arrival. For routing, we have learned that the earlier we can warn about relevant matters ahead in time, the better the overall result for the voyage will be. The most optimal speed is a tool to ensure that the earnings for the voyage is kept at a level benefiting our platform most. Executing speed on power avoids spikes in consumption. Alerts are automated and always looking ahead. So what we do is we gather the AIS, the weather, the data from all our vessels, from our suppliers, and also from algorithms or from systems, and we store it in a business intelligence system data warehouse, where we can provide 24/7, 365 automatic monitoring and guidance for the entire fleet, for the entire world. Business intelligence integration with high data quality. We use cutting-edge data from external vendors where we can. Could be algorithms, new ideas, new data providers, data flow, high-frequent data. We basically analyze the process from cradle to cradle, meaning from before the beginning of the estimate, where we go to the customer, and till after the arrival. And we try to make use of industry best practice when we implement new processes for our voyage execution. Such things can be seasonal routing, it can be fuel curves, optimal speed calculation, voyage planning, weather routing, actual consumption tables, dashboard overview, two-way data between office and vessel. We spend actually years in analyzing the added wave resistance, which is being used in calculating the most optimal speed. We build and develop alerts, push alerts to the vessels. We estimate, we calculate and look at the difference between the estimate and the actual consumption and speed and time and earning and demurrage for the entire voyage. A very recent example of what is not supposed to happen was actually that our systems failed. We had an incident in our data warehouse, and one of our vessels were not receiving timely alerts. It should also be said that the customer had provided their own routing for the vessel, and the vessel sadly ended up cross-Pacific in some very bad weather, and the vessel ended up in several damages on the main deck. So basically what happened was the vessels were crossing the Pacific, and heavy weather came up ahead of the vessel. The vessel could have been pre-warned. However, it did not happen, also because our systems failed, but that's not an excuse. He also has the weather forecast on board. Anyway, the result was that the vessel ended up in significant wind and wave, and took in a lot of water on deck and made some significant damages to the main deck. Had the vessel been pre-warned, had we been able to see this happening before it actually happened, we would obviously have guided the vessel to avoid the bad weather area. Some of the things we can do with the data that we have available is we can look for all our voyages, and we can monitor the wave heights. Wave heights is for a tanker the weather factor that has the most significant impact on the vessel speed, and as seen before in the last example, it also sometimes results in damages to the vessel. It should be said that the previous result is a very, very rare thing we see in TORM. We have actually managed to reduce the heavy weather incidents with 95%, basically because of all this pre-warning alerting systems that we have set up. How we can use the data proactively is we can measure our operators' ability and also our seafarers' ability to avoid the bad weather, not to penalize them, but to use it proactively to avoid getting into these heavy weather areas when they do the routing and the navigation going ahead. So we use the data to track the vessel movements while gathering the conditions from external providers. It enables someone like me and my colleagues in operations to gain knowledge about areas to improve. It also has the benefit of enabling better understanding as to why the individual voyages may have performed outside expectations, so that we can benefit from this learning and implement it into future voyages. Example, avoiding bad weather, which is easing our overall results. For the vessels themselves, we have also changed how we order, how we execute the voyage order, so that we ask them to reduce the load on the main engine when we see bad weather, typically to around 30%. Obviously, unless the conditions are supporting the vessel speed and consumption. So if it's against, we order them to reduce the speed. For the engine setting, we use the torque or the power depending on the system capabilities on board, so that we fix, example, torque, and in case we then see bad weather coming in, the speed will never go up. It will also always be kept at the constant torque, thereby the speed will go down. We avoid some excessive consumers by doing so. In the past, we had a lot of our vessels increasing the RPM in bad weather in order to force the instructed speed. But if we look at the charter parties, and now also if we look at our voyage orders, there is no expectation of high speed or ordered speed in bad weather, which is natural for most people. But for a customer who has a dialogue with the captain, they may not have that level of understanding. So now we have made it very firm, and we also support and monitor and alert if the vessels are seen not following these instructions. The overall benefit for the voyage, as you'll see on the schematic here, is that if we keep a constant power, we automatically reduce the speed, because if you encounter heavy seas, speed will drop at constant power, and then you can always correct the speed to accommodate for the losses after the bad weather. Overall, the consumption improves. That's the difference between the red and the green, where the red is if you constantly maintain a certain speed by increasing the consumption in bad weather, and then thereafter reducing the RPM in better weather, against having a constant consumption throughout the entire voyage. We also very often see better ETAs, but that's not the key here. The key here is this potentially saving in the fuel consumption. What we use all our data for the alerting is that we now have data in our system for all, it could be areas, geofenced areas where we do not, where we prefer to avoid seeing the vessel sailing in. It could be for many reasons. It could be piracy, it could be navigational hazards, it could be many other things as well. And we also have data in, such as, example, high waves, extreme high waves. We also have data for cyclones. Cyclone is a very dangerous size, but sometimes cyclones has very low intensity. So obviously we shouldn't, deviate for a very low intensity cyclone. But we have data for the intensity as well. We also have mapped all the icebergs in the world from NASA and from satellites. We also have, if you are aware of this Newfoundland floating ice limit zone that happens every year. So we map it and we make sure that it's geofenced and daily updated in our systems, so that in case a vessel route is penetrating these areas within a certain limit, then it will be alerted. High winds, high seas, and extreme high seas, as already said. It basically means that if a vessel on the route is penetrating an area that we would like to avoid, again, irrespective of type of area, then we'll get an alert, and this alert will also be pushed to the captain himself. If, example, an AIS position is also breaching this area, there will also be an escalation alert, so that we push messages to relevant resources. So we have our safety team, we could have a vetting, we could have our vessel manager, we could have our operators, we could have myself, who is on the routing side, and we also have the captain on board or the chief engineer on board, who would then receive a push message informing him that something ahead in time is expected to happen, unless he takes the appropriate actions to avoid it. Should the captain not see the message, not react on the message, there are always other receivers on the push messages in order for them to follow up and make sure that any danger is avoided. It's especially with ice, it's with high intensity cyclones, and it's with extreme seas that we see the sort of the biggest benefit from this, because if a vessel is trying to process through an area with very high seas, we obviously have the risk of damages. We have floating cargo, so that's not where we have the highest risk. However, we do see damages on vessels if they encounter very bad weather, and as I said earlier, we have actually reduced the amount of heavy weather damages at 95%, so that we can proactively warn the seafarers to avoid these things. That was what I brought with me today. I thank you for listening in, and if you have any questions, I should hopefully be able to answer those questions.
Thank you to Lajos. Are you with us now, Lajos?
Yes, I'm also here.
Nice to see you. So I can see there's a lot of activity in the Q&A section, but I would like to ask you a question, if I may, on you showed this heavy weather incident and the damages to the vessel. What is it with the captain and the crew? How are they? I mean, if they are not notified, don't they have other means or anything else to avoid these kinds of situations? I mean, they're out there.
No, but they do, and it's a forever and never-ending and ongoing discussion in our office, together with many other professionals just like ourselves, that the captain on board should obviously make the decision by himself. But what we see sometimes is, as I also mentioned, that some captains feel sometimes it can be difficult for a captain to go to a customer and say, hey, I would like to take a route. It's 500 nautical miles longer compared to the shortest. But I do this because I think the weather will be better. And then you would have an endless discussion again and again. And it's not that he can't do it. It's what we see is that some captains, they prefer to take the shortest, because then there'll be least questions from the charterers. What I also see is that then if I'm involved and I explain the situation, the charterers, they will calm down, they'll ease off, and the captain is permitted to do whatever he should have done in the first place. So it's not an easy answer that I give you, but I can only tell you what we see day to day.
Okay, so it's some sort of living up to expectations towards professional knowledge.
That's what we see, yes, and then sometimes it ends up terrible.
Okay. Can I ask you also? I mean, all these software providers that you have that's delivering products for you for planning the voyages. Now this was a before 9 case, and there was some damages there. Do they provide you anything with so you can see the responses on the vessel? I mean, if you're looking ahead and you see severe weather, is there any way you can see, okay, then the responses on this vessel will be like this? Is there anything involved? I mean, from a safety perspective?
Well, we do. So all of our safety teams, they have access to the system themselves and to the weather themselves, if that's what you're referring to. But to the extent of damages, you know, at a certain before level, we don't have that level of details. No.
Okay. All right. Okay. Okay. Thank you, Lajos. I think we'll, if you'll stand by for the Q&A section, then we'll get back to you, I hope, with some more questions. But thank you for the presentation. Very nice.
Will do. And thank you.
So we'll jump on to the next presenter. This is from Navtor, Timo Essers. He will be presenting on safe navigation and performance optimization. And Timo, he has a background also as a navigation officer. He sailed in many different ship types, and he's been with Navtor for a couple of years as a product manager. And please, Timo, go ahead with your presentation.
Yes, thank you. And indeed, thank you for the introduction. I'm very excited and delighted to take part in this event and representing Navtor here. So indeed, background in navigation, working as a product manager for Navtor now for a couple of years, and especially focusing on the safe navigation part by passage planner modules and also the of course newly launched products. We have Nav Fleet, which I'm gonna show you now in my presentation. So let me see. Here we go. So here is Navtor is let me see. Okay, here we go. So we're Navtor evolved. Navtor found sea first daylight in 2011, now existing in 10 years, and evolved from a global or from a local Norwegian player, rapidly growing and in success and customers, now having a global reach all over the world. How does that come? We started as a chart distributor with main focus on e-navigation and e-navigational solutions, and of course the electronic navigational charts. Now we're also looking at performance, since we think these items are very close related. We have shipping analytics, and we have the OEM and SDK departments, which are the software development kits which we develop for the active OEMs in the industry. So we basically have a coverage of total the ship operations, and this is our e-navigation infrastructure, the Navtor suite as we call it. So what we have here, this is the Nav Cloud. Nav Cloud is the heart of everything. We have server, shore, and cloud storage, and a cloud database on which we, of course, share valuable navigational data to what we call the Navbox, which I will elaborate further on and in the next slides. And this Navbox is a hardware unit installed on a vessel, connected to the vessel's sensor interfaces and communicating with the actors, and also with what we call the Nav Station, which is a route planning station. So also getting data back from both actors, Nav Station, and sharing this to Nav Cloud, and again distributing this to our shoreside platforms. So what is this Navbox? Here is shown the hardware units, these Navbox. We do seamless and automatic updating from all these navigational data, ENCs, ADPs, AMPs, nav area warnings, weather data, all these data going through the Navbox in a cyber secure environment, and directly share it with your actors and your bridge desktop. So it's a safe environment, and it's also reducing the workload and eliminating the risk for wrong update installations of charts. Basically, there's no need for cumbersome installation downloads by means of email or from the internet, and then putting it on an USB stick or using DVDs. All of this is not relevant anymore if you have the nav box installed on board. Besides that, of course, the nav box is a valuable source since it's connected to the bridge interfaces with valuable sensor data shared with shoreside as well. So what we have our on-board platform is called the Nav Station. Simple, seamless, and integrated is how we advertise it. And all the information you need to plan optimal vessel voyages in one place at your fingertip. As I earlier mentioned, Navtor is also developing software development kits for the ACTIS industry. But our own platform, Nav Station, is built on the same technology. It's built on navigational charts, which is the core of the platform, actually. But we're not restricted to the ISO standards that our ACTIS are limited to. So this, of course, gives us the freedom to, of course, display on top of these up-to-date ENCs large amounts of other valuable data relevant for safe navigation and the appraisal stage for your passage plan. So, of course, we have the ENCs up-to-date coming into the Navbox ideally, and the same ENCs updated through the Navbox is the same ENCs which you will plan or monitor your voyage on in the ACTIS as well. So then we have the AAO, the Admiralty Information Overlay with the temporary and preliminary notices available. And in addition to that, we have the route planning. Route planning will be done exactly same as in the ACTIS. You can do a route check just as you do in the ACTIS. Of course, we have the ADP, the Admiralty digital publications, the ATT, Admiralty list of flights, and the Admiralty radio signals. We have pulled the data from these digital sources and present them geo-referred in an interactive way on top of the ENC cells. We have the AMP, the Admiralty sailing directions available. We have the IMO publications through EPUB reader, weather overlay. I think the previous presentation by TORM will show only how important weather is. We have nav area warnings also coming in through the nav box, always up to date. Environmental regulations always playing a bigger role in current day navigation. And all of this data, important to mention, is also collected, gathered, and utilized in a passage plan, of course, which is reducing the workload on board drastically. We have maneuvering assistant, weather routing, and we have user layers available. And we're developing, of course, in the background, even more and more valuable layers, which makes it more easy for the user on board, of course. Our award-winning passage plan, as I mentioned, very valuable solution, awarded for its innovation and also its accuracy. It's a highly compliant product. I'm very proud to share that since the launch of our passage planning module, we actually none of our users had any non-compliance observations on the passage plan. So of course, reducing the workload and then of course automatic logging and calculations. We have advanced UKC calculation algorithms which can be done for every particular leg with automatic water depth picking algorithms available. And then of course, yeah, again, the value of weather. And then of course a passage plan made on top of an ENC chart and then with the weather data available in the same station, of course, is very valuable. We have the weather overlay and we have weather routing, optimal ship routing is what we call it, OSR, all available in one planning station. Now, these optimal ship routing, you basically make a route within Nav Station, and then you actually simulate the impact of weather and meteorological and oceanographical circumstances on your legs, on the planned legs, and see if there's any need for justifications. You also can share your passage plan with the intended route to shore side and receive an evaluated route back from professionals on shore. Digital logbooks is something we recently have been looking into and currently are proud to present as well. So go paperless with certified logbooks. The benefits, of course, going digital, measuring it with the traditional log keeping is basically just a stupid piece of paper consuming space on board, and the data is just there and has no function at all. only being called up when there is an audit. I mean, digitalizing these data, approved, flag state approved, and Lloyd's Register approved digital logbook solutions, which we offer right now. Digitizing the data, of course, creates much more transparency, and having the data in a digital format can be consumed, of course, as well, and used for advanced analytics when it comes to vessel performance. So vessel performance is what I'm going to talk about right now. Again, our ecosystem, as I mentioned earlier, I will quickly click through this sheet. Nav Station, ACDIS, Navbox, position data, other data, passage plan data, shared to our shore solution, which we name Nav Fleet. So we have the Nav Station on board, Nav Fleet on shore side, and of course, it's a total operations platform. So what does Nav Fleet give you? Nav Fleet, of course, all passage plans made on board, once they're approved, they will be visible within the Nav Fleet solution. And Nav Fleet, of course, also has the route format. Also, what you can see through the Navbox, of course, the Navbox is connected to the AIS, has amazing features, which of course also, by the connection to the AIS, can also display the vessels, the AIS target around the owned vessels, giving you a very realistic picture of what's actually happening around your vessel at that very moment. Also, of course, you can measure if your vessel is on track, on schedule. If it's deviating from it, you can get push notifications if there's any deviation from the intended route or intended schedule. And in addition to that, of course, you can also see measure the vessel performance if they are in accordance with the charter party requirements. Having this in addition, all the tools you need at your fingertips, lots of focus on performance these days, also available in Nav Station, or my apologies, in Nav Fleet, through Nav Fleet TRAS solutions, how we call it. And these Nav Fleet TRAS solutions are, Nav Fleet TRAS solutions will give you advanced analytics and performance models of your vessel based on inputs, reporting inputs, and of course based on vessel tracking as well. So basically, this is what Navtor has to offer. Navtor has a wide range of products and available, actually serving all branches within the maritime industry. We have vessels operating in the cruise industry, in the offshore industry, container industry, dry bulk and tanker industry. So that's basically, we have a full e-navigational suite and also performance analytics models. So basically, we have the full in-house package. So I'm available for additional questions right now, if any.
Thank you very much, Timo, for a very interesting presentation. It looks like an impressive suit you have there. So I can see there's some questions over in the Q&A section. Maybe you want to maybe answer them. But one thing is, if I look at your weather routing, so is it like, how does it work? So the crew, they plan a route on board using the route planner, and how is the weather? I mean, you can do a weather overlay, but how is the suggestions for the optimal route then coming? Who's providing that?
Basically, of course, we push the forecast models, the grid files, we push them through the Navbox in a user-defined interval. So depending on data size, and also you select the operational area for the route, we push the files through the Navbox and present them in the Nav Station. And of course, we have the OSR solution, which allows the user to simulate the route and the impact of the weather on the route, but you can also send through the Navbox in this cyber secure environment. You can share the route to shore side again. It will be analyzed by a professional, and you will receive update route suggestion back from shore side. Our partner in the a weather provider which we cooperate with is WNI, so Weather News International. So basically, you get a route analyzed by a meteorologist from shore side, get it back on the vessel, and you're safe to go.
So WNI is your provider on the weather suggestions. Yeah. Okay, thanks. All right. So all these layers you have in in your product. I mean, isn't there a risk that there's too much information? There's information overload. Do you have any feedback on that?
So we have them in layers, and of course you will monitor what's relevant for you. And it's not that we push everything and overpopulate the screen with all these layers, but of course the passage plan is actually pulling information. So if you have the passage plan subscription, it's pulling data from all these and gathering all the relevant data and data which is actually mandatory to include in the passage plan. We mainly focus on the highest standards, always looking at like OCIM, VIQ, and also the Intertanko standards, in addition to the IMO standards for the establishment of what we call or a base passage plan. But of course, it's a rather flexible solution which can be made compliant, of course, with company guidelines as well. So that's basically it. So the passage plan is actually collecting the data, but if you want to look up data, in addition, you just present and display a layer on top of the ENCs. And that's where I think where the value comes from, because you have all the data which you can reflect and measure to up-to-date charts as well. So if you get like a suggested route or a deviation, you can always look if the draft is also compliant, and so it's basically you have all the information at your fingertips, and you just call up the information relevant for you. That's
right. Okay, thank you. I saw you had some OEM. So if people want parts of your system,
yes,
you can integrate in other equipment, or how is that working?
Yeah, we have a very open attitude to cooperation, and of course we as we say, we also have the Navalytics. So if there's any analytics, what we have these nav boxes installed on the majority of our users and clients, as we call it, and where many operators are using terrestrial AIS data, we have waterborne AIS data that is connected to the ship sensors. So we have a much better coverage here as well. But of course, yeah, when it comes to software development kits, we have a very open attitude, and of course willing to cooperate with we already have many companies we're cooperating with, but we have very open attitude towards corporations. Yeah.
Okay, thank you. If you stay tuned for the Q&A session,
I will. Thank you.
Some more for you, but thank you for your presentation. It was very interesting.
Thank you.
And the next presenter is from StormGeo. It's Michael O'Brien. He's Vice President of Operation, and his subject is targeting decarbonization with optimization. So Michael, he also have a sailing background, as so many others in this forum today, and he's been working with voyage efficiency and optimization from a product angle, but also from a business development angle in StormGeo, and now he's the global head of the StormGeo operations. So Michael, please go ahead with your presentation.
All right, well, thank you very much, Soren, for that, and thank you to the organizers. I want to actually start things off today with a little bit of a question. Do you recall something from the early days of your training that really kind of resonates with you still? Something that you're holding on and it's really very relevant to you today? And of course, I can't see anybody raising their hand, but I'll go ahead and raise mine, because I had to memorize something back in 1985. And at the time, I thought it was just a forced memorization tactic at the Maritime College in New York. But I really had no idea how much it would become like a guiding principle for me going forward. And this is it's a saying written by Felix Reisenberg. He was an early president of the Maritime College, and it goes like this: the sea is selective, slow in recognition of effort and aptitude, but fast in sinking the unfit. And I think that could be taken in any number of ways, but I've always taken it as a lesson in not being apathetic and not taking things for granted. And this is something certainly I take to work with me each and every day. And it's something that all of us at StormGeo embrace, because we know we're working in a very complex environment in the marine world. And whether it's training are advanced algorithms with thousands and millions of data points, or whether it's taking a telephone call from a captain in the middle of the ocean at 2 o'clock in the morning, or speaking to a client, or training our staff, it's always with this understanding that vessels, there's lives, there's vessels, there's cargo, and there's economic outcomes that are really, really dependent on us being at the top of our game each and every day. So if I move along here, the organizers had indicated to us that there was a mission, and that mission is to identify cost-effective solutions to enhance vessel safety and to enhance efficiency while protecting the environment. And I think that's what I want to try and focus on today, and looking at several different parameters and challenges that we try and solve. And we'll go ahead and start with the safety of the crew, the vessel, and the cargo. And this goes without saying, in all of our products, this is a paramount tenet of what we're trying to achieve. We look to maximize voyage performance in terms of the economic outcomes. We're looking to optimize the vessel performance in terms of vessel motions. Am I getting into parametric rolling situations? Am I getting into high wave groups? Is my engine or my diesel generators operating as efficiently as they possibly could? We are ensuring navigational compliance, right? We're looking at, do I have the proper electronic navigation charts? Do I have the proper publications to be quote unquote seaworthy for that particular voyage from a compliance standpoint? And then we have the environmental compliance, and that's handled very nicely in our S-Insight module. And if you're looking at things like MRV, IMO DCS, newer regulations like the cargo, the carbon intensity indicator, or even voluntary programs like Sea Cargo Charter, these are things that the S-Suite, in particular S-Insight, is addressing very, very well. And again, along the lines of what the organizers are looking to have us touch on, I want to start and take a look at a little bit of a case study here. And it's looking mainly at the efficiency aspect of things, but realizing that when we try and target one problem, we're looking to make sure that it's scalable across a range of problems. Certainly, we don't want to make another parameter more difficult to solve by solving this one. So I'll start off by talking a little bit about the concept of constant power versus constant RPM. And at StormGeo for many, many years, we've supported and promoted the notion of constant power. But starting here with a constant RPM, you can see what tends to happen is that the COM sea speed is inconsistent. The main engine power is not consistent. And as a result, the main engine consumption rate is going to vary depending on the resistance against the hull. And I think if you take a look at the graph at the bottom of the screen, you can see that gray line is indicating a constant application of RPMs, and all of these other parameters are varying up and down. I think the area to take most note of is where you see this, I guess we'll call it a purple line, kind of diving down, right? This is the speed of the vessel, and these two parameters that are peaking here are the main engine consumption and the main engine power, right? So what's happening in this solution, people are trying to overcome the influence of weather by applying more power and more main engine consumption. And this has obvious impacts on efficiency, but it has compounding effects on vessel safety, right? If I'm applying more power into the face of heavy weather, I have a better chance of encountering some kind of a vessel motion, which is going to be adverse, potentially damaging the vessel or the cargo. And of course, by applying that additional power, I'm getting absolutely no better speed, but I'm emitting much, much more in the way of CO2 into the atmosphere. So again, we're looking at one particular problem here, solving this constant RPM issue, but it has compounding impacts for decarbonization and for vessel safety. Now shifting over to what we've always embraced, which is the concept of constant power. And with constant power, we're looking at a COM-C speed, which is rather consistent. We have a main engine consumption rate, which is rather consistent, but the RPMs will vary depending on the impact of the weather. And that's pretty clear to see here in this image. We have the red line is representing the engine power consistent through this example. And then we have this green line, which is representing the main engine fuel consumption. And then the average speed and the RPMs are really varying depending on the intensity of the weather. So again, looking at that area where the lines come down into a bit of a valley here, you'll notice that we're consuming the exact same amount of fuel, but we're allowing the RPMs to come down. We're allowing the ship to naturally slow down. And this is introducing a great deal of efficiency into the voyage. And then conversely to the RPM solution, it's impacting the environment by greatly reducing the amount of CO2 we're emitting. And it's also introducing a level of safety, right? Because I'm not trying to plow into that heavy weather and increasing the risk of having these adverse vessel motions. Again, we operate under this premise of solve one, solve two, solve as many problems as possible, and not making other challenges more complicated to solve. And if we were to compare it, put it all together, we have a voyage here, which is from Rotterdam over to Savannah. It's a liner vessel, so they have a fixed arrival time. Therefore, the steaming hours are the same for both the constant power and the constant RPM analysis at 326.4. But you'll notice that on the constant power analysis that we came in at 421.6 metric tons of main engine consumption, as opposed to 438.1 metric tons with a constant RPM. And again, coupled with this increase in efficiency we're contributing towards decarbonization, and we're contributing towards the safety of the voyage. Taking a bit of a more, I'd say, a more holistic view. On this screen here, we have three different routes. And what I'll do is I want to just talk a little bit about how we achieve the safety component here. And this is just one brief example. We'll pretend this is the middle of the North Pacific wintertime. And this red arrow is more or less representative of a common low track that takes place in the Pacific winter. You have a nice strong high pressure that sets up over the Bering Strait. The lows generate up off of Japan or off the Kuril Islands, and they tend to run south of that area of high pressure and then up into the Gulf of Alaska. So you can imagine on these two routes that are passing to the south of the low track, I have all of this northwesterly wind and swell bearing down deep into the lower latitudes of the North Pacific. And oftentimes the thought is, well, I'm heading further south, so I should be better off. But in reality, in many cases, you're heading into a much more adverse weather regime while at the same time adding distance. And then what we do is we try and get the vessel into situations where we can, what we call top the low track, right? Passing north of the primary low track and getting the vessel into conditions more aft of the beam. And in addition to putting the conditions more aft of the beam, we also find ourselves avoiding these mid-latitudes of the Pacific where we tend to have east-setting ocean currents of about a half a knot or so. And it's this combination of looking at the weather and the ocean currents, but on top of that, we're looking at the vessel age. What cargo are you carrying? What's your stability? Is there free surface issues? Do you have a high GM? Are you going to be rolling in a stiff way, or are you going to be rolling in a tender fashion? Are there specifics coming from the captain as far as requirements they have, or are there specifics coming from the operator as to voyage goals? All these come together to find the most efficient route. And then when you tie it together in terms of decarbonization, it's really very interesting, right? Because if you look at the far right-hand column here, you'll notice that the carbon intensity for all three of these routes are pretty similar. In fact, the longest route has the best carbon intensity indicator. And that's why it's important that you don't look at things one-dimensionally. It's a very complex paradigm, and what we try and do is solve it from many different angles, because by getting the ship onto this most efficient route, not only are we providing a really great carbon intensity value, but we're saving 346 metric tons of CO2 as compared to the Central Pacific Rumline route, and almost 900 metric tons of CO2 mass compared to the southern route. Again, it's bringing decarbonization, efficiency, and voyage safety all under one package, because you can solve many things rather than just tackling one. And I've been talking about how we're attacking all of these different challenges, and we're doing that through something that's called the S-Suite. And the S-Suite starts with what we call S-Planner. S-Planner is an advanced route optimization and advanced weather system. It has a highly designed and highly advanced route optimization algorithm. If I'm trying to get from point A to point B, and I want to consider it from a fixed arrival standpoint, I want to consider it from a dual optimization standpoint, dual speed optimization, where I have one speed outside of ECA and one speed inside of ECA. If I'm looking at it from a least cost perspective, I can put in the higher rates and the fuel costs, and I can also look at it from a least consumption perspective. And of course, the S-Planner has a key component of providing you all the information that you need with regard to your electronic navigation chart needs and your all publications, like I said earlier, to make that voyage seaworthy from a navigational compliance standpoint. And this is all sitting on board the vessel. And the vessel then has the ability to report back to StormGeo through what we call the S-Insight log. It's an advanced reporting system, hundreds of parameters of data validations, and we have the ability to also ensure a proper sequencing of that data, because anybody out there who's dealing with MRV or IMO DCS realizes that having the data valid but also in a proper sequence is so important. And from there, we go into the S routing. I've talked a lot about that already, so I'll just say that it's taking all of these voyage parameters and all of these environmental parameters and providing an optimal route. And on top of that, for liner vessels, we can optimize the main engine power setting to achieve that arrival time with the least amount of fuel consumption, the least amount of GHG release, and optimize safety. And even for vessels that are sailing like in a tramper, where you might be operating at a fixed commercial speed, we have the ability to look at that from a constant power angle as well, allowing that commercial speed to stay at a constant power, but recommending RPMs that'll account for the advance of weather. And this is all kind of anchored by our end of voyage team, which has world-class charter party compliance reports from tankers to dry bulk and across the board, and looking at vessel performance in general. And of course, there's communication from the S routing right back to the ship. And all of this comes into S-Insight. And S-Insight is this platform that encapsulates all your commercial needs, all of your technical needs, and all of your environmental compliance in one location. And this is where you're going to see a map of your fleet. You're going to be able to see alerts. You're going to be able to see advice, prescriptive measures coming out of the fleet performance team back to the ship. It could be something like the fleet performance team notices that your electrical needs can be solved by running one diesel engine, but we're seeing that you're consuming on 2 diesel engines, diesel generators. So the team can report back and say, give this advice to try and limit the amount of consumption or excess consumption. And of course, it all comes back to the office. And that is what we call the S-Suite. And it's looking to solve all these various problems that we deal with in the industry today. And again, the S-Suite, we're looking at it from a safety, efficiency, and optimization standpoint, and a very, I would say, dedicated standpoint, knowing that we're dealing with a very complex marine environment. And I thank you for your attention.
Thanks a lot, Michael. Very interesting. An impressive suite of products here. I just have one question because I think we are a little bit over time. But so when the route is optimized, I mean, you mentioned algorithms. That algorithms optimize the route. Are there any human intervention in this, or is it purely computer?
Yeah, that's a great question. So, the algorithms can live in the S planner independently, and the captain can use it at his discretion. However, the S routing and the S planner can live in conjunction with one another, right? So the captain can have access to that data on board, and the human element, which is so important, and an area that I've been involved with for many, many years, is a key component of the S suite. So absolutely, it's not a completely, here you go, good luck algorithm. It's one where we have a very dedicated human element behind it.
Okay, so you have a team that give advice to the masters.
Yeah, absolutely, and we have a growing team, and we're changing our dynamic a little bit. We have a team now building up in the APAC region. We have a well-established team in Europe and a well-established team in North America. So we're looking to have, and we're always, of course, 24/7, but we're looking to have a more distributed team to have these dedicated resources for local and immediate action in those areas.
All right. Thanks a lot. But
thank you.
If you stay tuned for the Q&A session, then there's probably coming some more for you.
Will do. Thank you.
Okay. And now we have a new presenter. It's Christian Dahll from 2020 Bulkers Management. The title of the presentation is The Human Element. And Christian, surprisingly, also ex-sailor. And he's been working with Voyage Management for many years. He was in Høegh Autoliners before he came to 2020 Bulkers, and where he's head of the commercial operations. So please go ahead, Christian.
Thank you for inviting me, Soren. So first of all, as you mentioned, my role now is commercial operations. So it's a bit more commercial than I had previously in Høegh Autoliners, but nonetheless, it's the owner's perspective, which I will come back to. I have kept my presentation rather simple today, by purpose, I would say, because I want to sort of get my points from speaking, not so much from showing my presentation. I'll start off by introducing 2020 Bulkers, so you are aware of who I'm representing and what perspectives I have in this context. We have 8 new Newcastlemax dry bulk vessels built between 2019 and 2020, a rather fresh fleet. We are publicly listed with offices in Bermuda and Oslo. We have technical management by OSM in Bergen and Singapore. We have senior officers on board from the EU. All vessels are on long-term charters, so meaning we don't have the privilege of operating our vessels ourselves. They are basically commercially operated by third-party traders. And we have a performance monitoring system by StormGeo. Firstly, I want to make a point about having a ship owner's perspective. It's important to know when understanding my arguments and how I perceive reality in this context. I believe it's always prudent to ask the purpose and goal of any meeting first. So today, as was mentioned by Timo, is to identify the cost-efficient solutions to enhance vessel safety and efficiency while protecting the environment. Well, for such a big and important issue, the first thing we need to make clear is placement of responsibility. And I think it's also important for me to emphasize on that. We have heard quite a lot about all the sort of technological solutions up until now, so I want to make a point about the human element. Clearly, it's the dockholder who is ultimately responsible for management of the ship and its operations. But at the end of the day, it's your captain on board who is responsible for daily operation and acting on the guidelines and rules that has been set for him or her. So from my perspective, it's of utmost importance to define the lines of responsibility and mandates to avoid any misunderstandings, which I have seen plenty of during my career, both at sea and also ashore. When sitting in an office sort of thousands of miles away, some might try to hide away from challenges and responsibilities, while others might be tempted to micromanage and operate remotely. And I believe we all need to spend some time to find the balance between the two. Again, when it comes to safety, it's extremely important that we are very clear about responsibilities and expectations. So why am I spending the first part of this presentation is talking about responsibility? Well, it's important not to get sidetracked and to lose focus while trying to figure out how to get better and finding sort of tomorrow's solutions. Talking too much about the future and digitalization can be a great distraction for many of us, both ashore and then also on board. But the beauty of the digital age is our capability to work efficiently and our ability to collect large amounts of information, as we have seen from the previous presentations. So to have a good overview of things, we must be able to monitor and analyze, which is, I guess, in the year 2021 is a bit of a no-brainer. But again, while monitoring, it's important not to get confused about responsibility and micromanagement, and giving the captain on board the impression that you're trying to do his job, that can truly be a trap that you don't want to get into. I think my presentation ended up being a little bit more, how to say, philosophical than my initial intention was. So I'll try to squeeze in a slide to describe our tools, again, as ship owner, not manager. We are deliberately keeping it simple in 2020 Bulkers. I'm not going to answer on behalf of our technical managers, but this is, again, from an owner's perspective. As we have a clear expectation towards our appointed technical manager to ensure for safe and efficient operation. Same goes with our captains. And also, as I mentioned, weather routing, that's a no-brainer these days. Same goes for fuel efficiency monitoring and general fleet monitoring. As also I mentioned, we use StormGeo we're very satisfied with those tools. Which works very well for both daily observations and also analytics. And to further prove my point on the importance of the human factor, I think until this day, every single automated performance claim report that we have received has been concluded to our favor after human analysis and interference. So that's a point I want to make. So what is digitalization? I don't have time to leave that question hanging for too long today, but I believe we all should give it some thought from time to time. First, we got email, obviously Excel sheets and digital instruments. Then we had the web-based services and some automated processing. And then what's the next step? Firstly, there should be no doubt that I'm a believer of automation and digitalization. I strongly hope that all the disruptive technology out there will help us in the direction of even safer and cleaner operation in the future. And I think we're dependent on it, obviously, to sort of keep the world moving on. However, I also believe that the way we communicate the concept of digitalization is creating quite a lot of distractions these days, and has been doing so for the last few years. There's a fine balance between getting the attention of the the shipping community to drive changes and the honest selling point of the actual and current benefits of implementing digital tools. I think many suppliers, both from the hardware and the software companies, have during the last few years given us the impression that we sort of stand on the edge of post-human age with AI and automation, predictive maintenance, sensors, web-based dashboards that are going to solve all our problems like a miracle. I've tried some of them, or many of them actually, both sort of in theory as a desktop exercise and also in real life practice. And it's easier said than done. And I think even sometimes it's not viable at all. It might be, I don't know, it might be that shipping is lagging compared to other industries, but the complexity of managing steel and combustion engines sort of at open sea and salt water is probably very underestimated. So as you know, many of us who have been sailing, it's endless variables out there. Again, just to make a point of it, my purpose is not to be negative or even sort of reactionary. I'm just trying to be realistic, to focus on how we make progress here and now with the resources we do have available here now. I mean, we will eventually get smarter and better. At the same time, it's important part of our job to ensure safety and efficiency in real life or in real time. So is it already controversial to claim that the human element is and will be the most important factor to ship operation in any foreseeable future? I realize that most accidents are said to be caused by human failure, but this is often a result of humans using unfamiliar technology in some form, or even the lack of proper training and procedures. So while artificial intelligence is still, at least to me, is science fiction, I think the interaction between humans and technology will be the main obstacle in the years to come. I think I started hearing about, for instance, predictive maintenance and advanced digital control centers with big data flowing all around and unmanned deep sea shipping many years back. But still, I haven't seen any sort of sustainable and effective utilization of this yet. And I started stepping down on the amount of time I spend looking into this. And I think until this day, and in many years to come, our most important asset is the humans on board and ashore, of course. An engine is still nuts and bolts, and from the bridge we have unpredictable local weather and traffic, also controlled by humans. I think we have countless examples where humans fail in the effort to control and rely on technology, while even getting more and more dependent on computers to do its job. There's no doubt that technology will be even more dominant in the future, and its use will help us overcome challenges related to safety and environment, as we have seen. Since the day technology came into our lives. But it's also frustrating to understand the lack of understanding on the customer and end user needs. I think it's the selling point is often a little bit vague and a little tangible. And then again, I think it's important not to lose focus. The core of ship operation is still the human element. So in the meantime, I think we make sure that your humans work and give them the practical tools to make the best of their work. To admit, I mean, I think we're all a little bit lazy in nature. So back in the days, the move from sextant to GPS was more than welcome. And I think the tools of the future will be hopefully just as good. I think while trying to balance it all, make use of the latest technology and still be focusing on the human factor, we need to build a bridge between humans and technology. An extremely good investment for any shipping company is defining the role as a translator between tech and core business. So So in my experience, I meet a lot of people with great skills in IT, great skills in the art of shipping, but I have to admit, I rarely meet people with both. On board, you need your captain and crew to understand how to use the tech, which have made available to them. They need to understand and agree on the benefits, and not the least, they need to be motivated to utilize it. And I think also ashore, you need to have simultaneous focus on both core business, which is sort of the money making, and your responsibilities as owner and operator, and also development towards the future, because that's also a responsibility to be involved in developing towards sort of a better and safer environment. And that's a balancing act. It's not easy. My mantra is be curious but realistic. I know the future will come, but just like sort of life, if you remember Marty McFly in Back to the Future, things didn't turn out quite like sort of the vision was back in 1985. But I think, you know, don't be afraid to actually be a little bit conservative. You know, I sure appreciate the efforts of all the engineers out there developing new cool stuff every day. But, you know, as a ship owner, our priority is keeping operations safe and efficient within affordable budgets right now. Sort of not to spend time where you shouldn't spend time. I think, you know, will our deep sea vessels be unmanned in the future? I'm not so sure that's going to happen, at least within my lifetime, or, you know, before I sort of hit retirement. But again, many others, they gave me the impression that this is, you know, just around the corner. And the last question, could sort of the last accident be avoided with more advanced technology? Maybe. But, you know, I've seen also examples where the bridge team got distracted by weather routing, forgetting to counter check with proper charts, and even ran aground. I know that Navtor, they explained, I guess technology has come a little bit further than this is only a few years back. So, you know, it's not that long ago. And I've seen accidents happen on the, you know, as the bridge team had their nose in the ECDIS and radar while forgetting to sort of look out the window, which is obviously one of the most important parts of how to operate the vessel. So I guess as a concluding remark, I'm not giving up on technology. I'm just trying to sort of do my job without losing focus and wasting time and money. So with that, thank you, and I'm happy to answer any questions after my presentation.
Thank you, Christian, for this interesting presentation and this angle to the digital world. I agree with you. The responsibility has to be the right places, and the people who are employed to do the different jobs, they have to do their different jobs, of course. So in general, I mean, we have moved in shipping. We have moved from absolutely no contact with the crew, or little contact with the crew, and independent seafarers, to more and more, let's say, dependent seafarers. I mean, we as digitalization, I mean, it gives us connectivity, it gives us access to here and now data, sure. So do you think it has done something with the crew? I mean,
yes, most definitely. I've seen sort of some terrible examples of captains sort of forgetting about their responsibility and mandates. And I think even throughout the last years, I've had the responsibility to take care of this. I've tried to reverse a little bit, giving the responsibility back to the captain, where it should be. And as I mentioned in my presentation, sort of, you know, my responsibility is giving him or her the tools to make use of technology, but instead of sort of blindly listening to the weather operator ashore, I'm telling the captain that please use your sort of own individual considerations and use technology as a backup. It's important not to sort of to give them the impression that the vessels are being operated by shore personnel.
Okay. All right. Thank you very much. I think we'll go on to the last presenter, but if you'll stay tuned for the Q&A session, we'll get back to you. Thank you for your presentation. So the last presenter will be from Wärtsilä. It's Maria Hernandez Martinez. She will present on integrated voyage planning. Maria is a professional meteorologist, and she has extensive experience from weather routing and owner-operator's perspective. And she's currently managing the voyage optimization products within Wärtsilä Voyage Fleet Operation Solutions. So welcome, Maria.
Thank you very much. Hi, everybody. Let me share my screen really quickly. And I hope it will appear soon. All right, can you see my presentation now? I hope you can. Yes, here we go. Thank you, everybody. I am the last one, so I will try to keep this interesting after all these nice presentations we've heard and all the different angles. Like Soren said, my name is Maria. I am here representing Wärtsilä Voyage today, and I am product lead for our voyage performance part within Wärtsilä Voyage in Voss. Today, with the focus of this seminar that we are having about ship navigation, route optimization, and then how to integrate safety and efficiency while ensuring that we are reducing emissions for our environment, I would like to touch upon the topic of voyage planning and what is our solution to the complexity around it today. So in order to do this, I will start by describing what are the challenges today, I think, in the maritime industry, present our solution that, does not, like referring to before presentation, not really a miracle, but trying also to stay realistic what we have right now. And then I will just make a quick summary of what we have discussed. But let's jump into it by describing today's challenges in the industry as we analyze them today. So when I think about voyage planning, I think of complexity. This is a word that has been sounding also today a lot in the other presentations. It's not a simple task. It's a task that involves several stakeholders, multiple tools, and multiple processes. We see commonly, unfortunately, that some of these tools do not talk to each other. So we don't have the same information at hand between the different parts that have to make a decision, right? And if we are not using the same information when we have to make a decision, this slows us down. This is not efficient and it's not optimal. I would like to exemplify this a little bit by considering this example. Imagine that we have a company that has an operations department, a technical team, and then we expand all this scenario to the master and the crew on board. When it comes to preparing a voyage, all these teams have a say on this, but focusing on different interests and having different goals. The operations team wants to maximize profitability. They have to consider and stay in control of the voyage planning during the execution also of the voyage, considering the commercial obligations they have towards the contract. This is one goal. Then we have technical team, which needs to be aware of the voyage execution, but then from a safety and compliance with regulation perspective. And at the end, in this example, we have the master and the crew, which, like it has also mentioned before, they have the final responsibility for the safe passage execution, but at the same time, considering the commercial instructions that they have received from the other side. To do this, nowadays, there are different tools. The industry provides a lot of different tools that execute these processes to reach these goals very well. But often these tools, they are disconnected, right? So for instance, if we talk of operations, they have distance tables, fuel curves, tools that create voyage calculations, and then also help or services from weather providers at the same time. That's for planning, but then for execution, then the master and the crew is usually using chart software. They have the ecdys's on board. And then to maintain the awareness of the situation, technical team, but also operations are using AIS tracking and then non-report information. And on top of this complexity, we also have the communication aspect, right? Traditionally done between emails and phone, but then there is a lot of information that can fall between the chairs if all this information does not talk to each other. In my experience, having these services separated, having these single systems that just focus on one of the aspects, and that this information is not compatible, it doesn't lead to any simplicity. On the contrary, it just enhances the complexity of the problem, basically. So, taking all these into account, we have considered our own solution for this. Again, not a miracle, but more merely combining the dots that we have right now. So what we think at Wärtsilä is we are thinking of FOSS, which is our fleet operation solution. And the idea is to integrate these separate processes, but using existing equipment on board. And yes, considering digitalization, of course, as much as possible. So what we are combining is fleet performance, weather routing, voyage planning and execution, and then ship-to-shore reporting. All this into one solution that is seamlessly integrated, and so that all these traditional separated solutions from different vendors, they all come together in one platform that shares the same data. And then it's visible to the different stakeholders on ship and on shore at the same time. We believe that compliance, safety, efficiency, and awareness, it can be combined in this integrated solution. And this brings us to this more collaborative voyage planning that I was referring at the start. And it helps us build towards a more smarter marine operation, and of course, in a profitable manner. This level of integration that we have, it can come in different formats, right? And it's absolutely seamless and cyber secure with the ecdys connected to the cloud. But we are now also expanding to other areas by also being software based if needed, and still maintaining this cybersecurity and this integration. But I am aware that this might also be very, on high level. So I would like to also show an example showing our actual tools on how we think of this and how this would work. So for this, I would show you this concept in practice of an integrated voyage planning. And we are going to consider a scenario in which, similar to what we were describing before, where we have operations team and then technical team at the same time, and the master and the crew on board, of course. In this example, we are in the office. Our commercial team, operations team, wants to plan a transatlantic passage, similar to also one of the ones that we have shown before, actually, from Rotterdam to, before was Savannah, this is to Houston. And yeah, we want to plan this voyage in the office, making sure it's properly shared later with the crew. So what we have is our web planner, which is the tool that you can see here, web-based solution that allows us to input a few parameters at the start, like port rotation, what is the vessel from our fleet that we want to use, and what would be the optimization method. For instance, a particular speed to comply with certain charter party requirements, or maybe to optimize by arrival time to make sure we don't miss a laycan. When we input these parameters, we can do this pre-planning on the shore side, following these commercial aspects. What happens then is that we have our AIR, Advanced Intelligent Auto-Routing System, that will calculate what is the most optimal route on the cloud. And this takes into account weather data, charts information, so it's navigationally safe, and also previous sailing patterns from different vessels and of different sizes. Together with this, we also have performance model, fuel consumption models that are generated through self-learning mathematical models that also use weather data, navigational data, speed position, and non-reports. And then this generates a vessel-specific fuel performance model that then tells us what is the estimated fuel consumption for a particular passage. This is done with only a few clicks. And once this is done, the beauty of this is that we can share this then with our crew. Here we go. Of course, we understand, and that's what we were mentioning before, that the crew, of course, is the master is the utmost responsible at the end of the day with the execution of this passage. So when we are making this very clear before this passage is shared with the onboard side, so the master then and the crew can do final necessary touches. But by doing this, we are able to share this pre-plan with onboard. And what we can see here is that the same route that has been created is automatically populated in our onboard tools. Of course, here now our tool provides some further steps for the crew and the master that have like the experience and of the navigation and safety navigation, basically, to finalize the steps to make this route fully safe. And the idea is that we want to provide tools that make this process shorter. It's a process that typically can take several hours, but by automating some manual processes, we can reduce this time to only like maybe half an hour time or something like that. An example of how we do this is that we provide automatically charts and publications that are going to be relevant to the route that is going to be sailed. Our system also performs automatic checks for safety that will be highlighted at the end of the process for the crew and the navigators to check. And at the same time, the route is created, so the crew can fine-tune the waypoints according to their knowledge, of course, but the basics are already done. And one detail I want to highlight is that in this case, we are receiving a route, which is the same route that comes from the shore, but this process can also start on board. So the crew can also input some initial parameters, and the automatic intelligent algorithm will also populate the route that is already safety navigational for the crew. Not only this, but we are also sharing weather data. So the same data that was available on shore, it's also available on board. So we are seeing the same information at different places at the same time. And this is very important because in one of the presentations that was shared before, it was mentioned this pain, no? That the crew has the experience, they are seeing some weather, they maybe want to update a little bit a route, but then maybe on shore we are seeing different information. So we are simplifying this communication and understandings by sharing the same data on each platform. Once the crew is satisfied with the plan, then it can be shared again with shore with any modifications that can happen or comments that the crew has added to the plan, so that then the shore can see exactly what the crew is sailing, and then there is this awareness and we can monitor this route, the same route that the vessel is sailing at on board. Another item that we also have is the underway reoptimization. And we are aware that sometimes this reoptimization on board can be a burden because when we have a new weather forecast, then there needs to be a lot of manual update. So we are trying to simplify this with a few clicks so that it reduces the burden and the manual work on board, and then we ensure safety, but of course optimization as well and efficiency. And how? Well, because when we have a new weather forecast, there is an alert on board and the crew can see this, and our system automatically checks whether there is a more safe route or a more optimal route. So in that sense, we are not only doing weather avoidance, but we are doing weather optimization. So we can also benefit from the weather on some cases. In this particular transatlantic voyage that I have picked, at the start we had a storm that was moving northeastwards, and the extent of the swells, they were tracking quite south. Therefore, our route selection at the start, the one that our system created, was one that was going further south, so a bit longer than the usual Great Circle. And that was to, of course, preserve safety and minimize exposure to adverse conditions. But a few days later, we have a new update, and we can see that the extent of the storm actually has gone a bit further north. Therefore, the swells are not so much south, so we are able to get a new route that tracks further north, like here, and it's more optimal and it remains safe. And just by 2 clicks, the crew has this information available, and then they can, if they want, accept this route and then start tracking the new route that brings them still safely south of these heavy swells, but as it's also more efficient. And the beauty, then now we can share again this with our onshore office. This shared of the same information, it's very important, and it doesn't only translate to this. Another example is, for example, Eta Exchange, right? So when we are changing the route, because we have new weather conditions, the ETA will change. So we are ensuring also this same visibility on both sides to ensure that we don't miss a laycan or that we don't burn extra fuel by having this misalignment or miscommunication on this information. Good. So to summarize, what we are trying to do basically is to integrate systems, communications, and processes that usually don't interact with themselves, and take into account at the same time safety and efficiency. And by doing this, we are ensuring integrated voyage planning and optimization, enhanced transparency between the different stakeholders, reduction on manual work, and all these we believe translates into time and fuel savings, and therefore reduction of emissions. Thank you so much for listening. I look forward to any questions you may have, and thanks to the organizers for having me today.
Thanks a lot, Maria. Very interesting presentation. There'll be a Q&A session now, but I just have one question. Just so these updates for when the storm is going more north, is it something that is detected in the algorithm, or are you having people sitting and looking?
Our algorithm is detecting this. So every time we have a new weather forecast, then our algorithm runs again, and then if there is an optimization, then this is highlighted for the crew.
Okay. So is it something that is done from Wärtsilä, or is it if I buy a product, for example, then I get it in my office? Can I sit and do whatever you do, or is it from you this optimization is coming?
You can also do it using our products if you have them, but this happens automatically in the cloud, so you will get a notification when this happens, so you don't have to have the burden to go and do it yourself. So you will just see it.
All right. Okay. Thank you. Very smart.
Thanks
a lot. So now all presenters have given their view on this, and there has been a lot of activity on the Q&A session. A lot of people have been asking questions, and a lot of people have been answering. So one thing I'm curious about is that now we have this digital world that we are living in, and in shipping, maybe the business model hasn't required this yet. We have lived with noon data reporting for a long time, and we are still living with it. So apparently the request for accurate data and accurate information, maybe it's not so high as we would want it to be. So my question is to you is how do you see this evolving? I mean, how do you see this going forward? Because from Navtor, with all the displays that you can, I mean, you can combine it to anything you like, and to Maria's and Michael's products. Where are you in 5 years? And what are your requirements from the owner-operator side? Because as we see it, there's still a lot of accidents. We see all these container losses. We see a lot of unfortunate things in navigation and optimization. So do we have a view on where should we go with this? Maybe we could start with you, Michael.
Sure. Yeah. Thanks for that question, Soren. Well, in terms of data reporting, I think we're heading towards a time where we're looking at more automated reports coming in, whether it's via AIS or high frequency data. These are all things that we're processing on a daily basis. Now, how that translates into the safety of the voyage, I think it's a close collaboration, And as Christian had mentioned, I think it's so important to realize that in the marine environment, many of us on this panel have sailed, and the moment that you take for granted the power of the sea is the moment that it comes back and can bite you pretty hard. So I think it's we're looking at a balance between technology and the human element to make sure that the two are working in harmony with one another, because if we're able to accomplish that, then I think we're in a position to greatly reduce these maritime accidents and save lives and save property.
All right. So what about you, Lajos? Do you have any requests on this? Do you have any wishes for this in the future? I cannot hear you speak. Can you please try again? No. All right. Can you try again, Lajos? No, I can't hear you. Okay, let's jump over to Timo. Do you have any feedback on this?
Yeah, how the future will embrace the digitization, I think is an unavoidable factor which we're going to. If you look at where the main focus of the navigator on board was navigation in the past, we have lots more reporting to do and more administration, more of an administrative burden, which is increasing all the time. And I think that digitalizing work processes will also be make it easier. Also, if you look at the amount of data, just give an example, like look at passage planning as an example, all the data in the appraisal stage, which the navigator has to process and consume. It's quite overwhelming, and I think everything that can be utilized automatically should be done automatically. Of course, it always comes down slightly to the interpretation of the person consuming the data. But I think when it comes to reduction and also transparency, with for example, where digital logbooks being all the log entries available on shoreside, and also where for example the shoreside can monitor the vessel's track, and just monitor the vessels and their performance, and also analyze it and also improve the work, the performance of the vessels and of the crew. I think that's a very nice thing. Weather, of course, as well. More that weather data available, where we have been looking at weather routing charts and pilot charts in the past. Now we have weather updates available every 3 hours, giving notifications to the crew. So the situational awareness is also enhanced by means of digital solutions. So that's my personal vision on digitalization and the maritime industry in relation to the maritime industry.
Sure. Thanks a lot. Are you with us now, Lajos?
I'm not sure. Can you hear me?
Yes, I can hear you.
Okay. Yeah, sorry about that. So this was a brilliant example of the technology not working when it was supposed to. So that's also what I put in my presentation. So yes, I think we need more. I think we can do better. I think we can build more. And yes, I think it sets more requirements to the seafarers. However, as this example just proved, technology only works for as long as it's been maintained. And that's also exactly what we have experienced in our company, that we can build many smart algorithms, and we can do better with more and more data. But as I think each one of you have all mentioned, it always goes back to the onboard qualifications and the onboard availability of systems. So that also sets some maybe new requirements for technology in the future on board. So I don't think we are there yet. I mean, I think there's a lot to do still, but I was 20 years in Maersk, and there was also, you know, we always had this, no matter how many smart systems you had, you should always be able to do it manually. And I think if you can do that, then you have done a lot. There was one comment I'd like to make a note on. This thing about containers being lost overboard at sea. Vessels are getting bigger and bigger and bigger, and it does set more and more and more requirements to the seafarers. But they also need new technology to be able to do their jobs better now that everything is getting bigger. So that was sort of just a 5 cent on my comment.
Thanks a lot. I agree with you. Christian, do you have any comments to share?
Not really anything except sort of repeating what I already said, that we try to remain or to maintain a fine balance between sort of being a little bit old-fashioned and keeping the captain's word holy, and also sort of at the same time exploring new technology a little bit sort of in the background, and only making use of technology when we know it's mature and know it's working. And personally, I have to say, you know, I receive, you know, I have the owner's sort of and customer's privilege of sitting and picking and choosing whatever I'm presented. But I have to be honest to say that, you know, I'm approached by too many people and too many companies with technology that is extremely vague, and they don't seem to sort of understand our needs, or even sort of our very basic requirements. And, you know, some manufacturers will expect us to sort of pour out money blindly to products that have no sort of defined purpose quite yet. And as I always say, I'm perfectly open to any technology or digital tools that will make my life easier and make us more effective, and make the vessels safer and more effective. But that's sort of my pledge to any of the developers out there, that you need to sort of prepare your selling point a little bit better, to sort of understand what's going on behind the curtains on the owner side. Yeah.
Thanks. That's a good message to send. So Maria, do you have any? Where are you in the coming years with your services and your product?
I think it's. I would like to continue with what Christian was saying, because I think he made a very, very valid point. So myself, I have been in both sides, right? I've been working in provider, but I have also been working in shipping company. And when I was there, I could see the pain of my colleagues, right? They have like a lot of work, they have a lot of burdens, a lot of things that they have to follow up, and be in constant awareness, because if you are aware and you can act fast and before the things have happened, then that's when you achieve better savings and better optimization. So of course, the solutions need to be targeting these problems. Sometimes I agree that we also try to be very fancy, but we don't have to forget what are also the actual struggles that happen both on shore and also at sea. And I think to some extent digitalization can do this. So it can help us, give us some of these processes, automatize some of them, so that then when you are doing the actual work, you don't have, like you said, you need to be able to do it yourself, but you don't have to do it yourself. Sometimes you need to just be able to validate if what you have given makes sense or not, and then based on that make decisions to optimize and do better, right? And drive your business like this. So I think that's what we should aim to be doing in the future. And of course, sometimes though, it's true that there can be some ideas that are revolutionary, and technology is there to teach us that and show us some things that maybe we don't even think it's possible now, but maybe they might be. But again, without forgetting the focus that what are the actual struggles and burdens that we have on shore and on board.
Mm-hmm. Yes, exactly. Good. Very good point. So we have looked at all the Q&A questions, and I think we have answered most of them along the ship or along the session here. There's one question that is coming here. Is this leading to more autonomous ships? I mean, Christian mentioned that we are very far from that, and maybe you will never get there. But do you think, in my view, what I see from my table is that with all the documentation that is needed, we need more people to take care of the documentation. But is this leading us to autonomous ships, or is it something that it's not really coming in many years? Do we have any views on that, the autonomous vessel? Michael?
Yeah, sure. Christian, please go ahead.
Okay, sorry. Just a short comment. I think we should, of course, be extremely careful about not being ambitious for future technology. I mean, who would have predicted the iPhone 20 years back? But at the same time, we also need to be careful about how much time we spend on being hopeful for the future. So I, as I said earlier, I had to step down the amount of time I spent reading about autonomous shipping and artificial intelligence, simply because I've heard about it for so many years already, and we moved like this far. But I'm totally sure it's going to happen at some point. Obviously, short sea first. I mean, I think the Yara Birkeland being planned here in Norway is going to be, I mean, their ambition is to have it automated in 2024. I have no idea if they're going to make that or not, but for deep sea shipping, not for many years to come.
Michael, you had a comment?
Yeah, I mean, I certainly don't have any kind of crystal ball on this, but I do feel that there is some time before we're fully autonomous. I could see maybe in the shorter term, and when I say shorter term, 15 years, where there could be a degree of almost remote control type activities going on, but you're essentially taking the duties from the vessel and putting them on the shore. And a lot of the stuff that we're talking about in terms of coordinating with individuals about how to optimize the route and how to do certain tasks are essentially happening from the shore rather than on the ship. That would be the next step I would potentially see. And then to go fully autonomous, where the vessel is making these decisions without any interaction, I see that as being a quite more distant, but certainly it'll happen. If technology continues to improve the way it does, I certainly see that happening. But it's all the stuff that we're doing right now, all of us here, that are contributing to that gradual step in the future. So I think it's pretty exciting to be part of the industry right now.
Yes. Any comments from other?
Well, maybe the way I see it also is we are taking it step by step. So full automation might be longer down the path potentially, but we are taking some steps towards it, and I think it's good to start, see what we can do, learn from it, and then develop further. So surely maybe the full automation, it's further in the future, but we can already take some steps. I think there are some things that we can automate and prove that works, and it helps with solving other problems. I think we are getting towards there.
Yeah.
I personally think I think autonomous shipping has absolutely future, and Navtor is already on the background involved with autonomous shipping projects. So, but it's a relatively new idea, and I think with everything that's new and is newly developed has to be improved afterwards. But there will always be, even with fully automated ships, autonomous ships, there will always be a human element involved when it comes to loading and discharging operations, mooring. So I mean, there always will be a human element involved, and also autonomous ships will have to be tracked and of course monitored. The performance of an autonomous ship will be not less important than a ship which is navigated by humans. So I guess there will always be a human element involved in any kind of way.
Thanks. But I think the time is up. I would like to thank you for giving your presentations. Very interesting all, I think, both from one side of the table and the other side of the table. And it's nice to see that there is this development in aids to safe navigation and voyage optimization. So thank you very much for showing up, and thank you to all the audience that we can see. But I hope there has been a lot. I can see on the Q&A there has been a lot of questions at least. There will be one more session tomorrow where we also will have 5 new presenters, and it will start at the same time as this one did today. But thank you all, and thank you for your participation. It was a pleasure.
Thank you, Soren.
Thank you, Soren.
Thank you very much, everybody.
Bye.
Bye.
Thank you.
Bye-bye.